collected 12 historical profiles of women scientists who made the field that I work in, which is nuclear physics, astrophysics. And Maria Göpper Meyer is obviously in the list, but we try to cover different regions, and we start, of course, with Marie Curie. We provide information on a lot of women that I think should really be remembered. So this was a project that, as we just heard, we want the public to also know about this. So the interesting thing, well, first, I just realized we made a mistake in the profile here, because we wrote that the headline was San Diego housewife wins Nobel Prize, but it was San Diego mother. So there's some difficulty sometimes in collecting a lot of information about all these women. But I wanted to point out that the information is being translated in like 20 languages. So if you don't mind, I will just post these on the chat. So if people are interested, we printed a lot of them. We've been giving them away at schools all in Europe, in the US. I know it's already November, but it's still 2022. And if anyone is interested, sorry, I just took a minute for this kind of advertisement, but I was really inspired by the talk.
Thank you very much. Thank you very much. I think we will be happy to repost it in our own webpage. And let me take the opportunity to make the nice transition to our roundtable. But before, let me thank again Melissa for her very nice and inspirational talk, and to all the speakers of today, and all those who would like to join the next session. So Laura, please take over. Jessica, you moderate.
Can I just jump in and ask, is everyone else having a funny issue with Melissa's camera?
Is there a funny issue?
I think it's changed. Yes. The camera has gone to a different camera.
Camera?
Yeah.
There?
Yeah, now again, yes.
It's fine?
Yeah, it's perfect.
Sorry.
No worries. Jess, if you don't mind, I'll share my screen for a second again and announce the round table, and then I would hand over to you.
Cool.
Okay. So let me do that. All right. We are. Oh, oops. All right. So it's my great pleasure to announce that our next session will be the roundtable. And it's an honor for us to have Dr. Jessica Wade here, who will moderate this session. Jess is a postdoc at Imperial College in London, and she really stands out for her activities to promote gender equality and equity in STEM. She has written a children's book on nanoscience. She has written over 1,000 articles on Wikipedia, which has brought her to the Buckingham Palace. So it's really, really an honor to have Jess here today to be the moderator of this roundtable discussion. And in addition to that, our plenary speakers, Dr. Maria Lugaro, Dr. Laura Green, Professor Dr. Lawrence Wood Matthews, Professor Dr. Melissa Franklin, and Professor Dr. Samaya Nisanko are here and have kindly agreed to join this roundtable discussion. So Jess, I will hand over to you, and the stage is yours.
Awesome. I think everyone is off camera, on camera, I mean, who's going to be in the discussion. But if we can just make sure. Yeah, awesome. Everyone's here. And I know everyone in the audience, you've probably heard from some people today, and you're going to hear from other of these extraordinary women tomorrow. So we can cover a little bit of research in the next hour, but we might focus more on kind of careers. We'll focus more on career stuff and really you know, what we can all do collectively to overcome barriers and have the extraordinary scientific careers that all of these incredible women have had. I think, you know, the talks so far at this have been really amazing and incredibly inspirational. And I hope everyone in the audience and everyone who watches the recordings of these knows how lucky they are to hear from these amazing people and to have them all in one place, and just feels that and uses that. I want to say hello especially to Adele, because I know Adele is here from the Philippines, because Adele organizes an incredible meetup. Here's Adele. Adele organizes an amazing meetup for physics students from the Philippines. And I'm imagining, Adele, you're getting a lot of fantastic ideas of who you need to invite for the physics meetup. So that's absolutely amazing. I'm so happy to see you in the audience. So I'm going to talk less, but kind of try and guide you through the incredible women that we have on the panel. I think that you already heard from Dr. Maria Ligaro. I might hand to you first, Maria, to introduce yourself properly to this audience. But Maria is an astrophysicist. She's had an extraordinarily international career. You know, when you look at where Maria's worked and the kind of roles she's had, it's quite incredible. Also raising children and really advocating, as you could see with that amazing calendar, for women scientists, but also for scientists who are parents. And I think if I hand the floor to you first to give a kind of couple of minutes perspective on your career in physics, and we'll go round and do this, and then I'll ask a few questions and then take questions from the audience for the rest of the time. So over to you, Maria.
Okay, thanks. I just have 3 quick slides, if it's okay that I share them. I thought I just prepare something that people can look at. So I study nuclear reaction inside stars. So I'm grateful for your talk, Melissa, because you already kind of introduced my field. This is what I do. Try to understand little small processes in big stars. My talk will be tomorrow at 3 p.m. And specifically tomorrow, I talk about low mass stars. There's a lot of astrophysical objects that are interesting from the nuclear physics point of view. But in half an hour, I decided to focus on low mass stars. So stars like the sun. And actually, these stars are very interesting because they can make elements up to lead, not gold, but lead they can make. Of course, if you Google me, you can find more information about my projects and what I do for research. And the talk tomorrow, I hope it explains a bit more. Yes, as you mentioned already, I was part of this project, Mothers in Astronomy, that was organized by these 3 colleagues, and I found it very inspiring. So it's a booklet that collects about 100 people, 100 physicists who are also mothers. Actually, my dream project is to make a fathers in astronomy as well, because I think that it's not that women should be classified more as parents than men are. So this would be, I hope, my future project. So yes, I have 4 children. And so if people are interested in talking about the work-life balance and family management, I'm interested in all these topics, of course. And just one last thing about myself that maybe it's curious. I never imagined I would be a scientist. I wanted to be a dancer, a ballet dancer, up about the age of 20. It was totally out of my radar to be a scientist. So in some sense, I'm still surprised today to be here doing physics. I love doing physics, and how it happened in my life, it was quite of a surprise. But I think it helped me to not take myself too seriously. And I think this has been an advantage for me, that I always find myself curious, but ready to change track, because I never know what's going to happen next. But definitely the passion for physics is what is pushing me to go forward and keep on doing this very exciting job that I feel very lucky to be able to do. Yes, thank you.
Thank you so much, Maria. And hopefully people can come up with some questions, about leading these projects and also about, being a parent and balancing multiple responsibilities and potentially moving internationally. I'm going to hand the floor now. I know we just heard from you, Professor Franklin, but it was such an incredible talk. And I just absolutely loved it. I've got a lot of questions about discovering you have a role model later on in your career, which we'll get to. But for everyone who didn't quite catch it from that amazing introduction, Professor Franklin is a particle physicist at Harvard. She was the first woman to get tenure in the physics department at Harvard, and also chaired the department. So, alongside being extraordinary in research, has been one of these people who's broken many barriers for everyone in this audience. So I wondered if you could just give your perspective and your experiences so far in your career.
Oh, my perspective. Yeah. Well, my impression of what's happening now is that my students are way better prepared to be scientists than I was, and way smarter and incredible and also funny. So I think the only problem now is, do they want to do physics? And do they bring their whole self to physics? I had a student come into my office and say, I'm a double major. When I go into my women and gender studies classes, I take all of me. I'm my whole self going in. And when I go to physics class, I just take the physics part, the physics math part. It's kind of really interesting to me. I know, yeah, this isn't really answering your question, but it was kind of really interesting to me that it's right. You want to go into a field where you can take your whole self into the discussion. So that's why I'm so very excited about trying to get students to write about what they think about physics, what they think about the ethics of physics, what they think about everything, not just women in physics, but just like everything. What do they think about escape velocity? Let your whole self be part of this thing we call physics. And I think, so I'm not worried about whether there's smart enough women. This is not a problem. I'm not worried about whether there's crazy enough women to go into physics, but I want them to come in with their whole self. And if I can do that at the university, I'm going to try my hardest.
That's amazing and perfect. And also I hope professors everywhere, certainly across Harvard, but actually in all physics departments, are listening. I think it's completely critical. We have quite a big physics education research group at Imperial. I work at Imperial in London, and the physics education research group are particularly looking at sense of belonging and how that's bringing your whole self to the classroom, to the lab, impact, everything from your degree results to your likelihood to go ahead and continue in a physics career. And I might bring in Professor Matthews here, because I know you're at Baylor. And obviously you all know Professor Matthews. She's spoken today on dusty plasmas, but Baylor have a very proactive program, the physics professionalism program. Am I right? I've read reviews of, I don't want to put you on the spot like this.
Actually,
no, but I'll put a link to it in the chat, but it's an extraordinary kind of way of educating undergraduates in physics that's saying to them, equality and diversity is incredibly important within physics, and that the environment which within we do physics, the questions we ask, who is and isn't at that table, is important for the science that we do. I'm assuming from your face I put you massively on the spot, so I'll ask you
I think you have the wrong person. Is it the physics professional program? It sounds like a great program, but that's not
definitely, I know you don't lead it, but it's definitely at Baylor. I'll come back to you. You go on and introduce yourself.
I check on that.
I'll come back to you, but if you want to introduce yourself and talk about your career a little bit, that would be great.
So yes, I'm at Baylor University, and I too was the first female hired in the department when I joined in 2000. So and I've gotten to have all of the ranks from lecturer and senior research scientist up through full professor, and now I'm the chair of the department. So I'm one of those unusual people that came back to work at the place where I did my undergraduate degree. And that's because I've been very fortunate to be at a place where I always felt like I belonged. And I had great professors, and I even had, when I graduated, there were 3 in our graduating class, and 2 of us were women. So we were the majority. So that's a little bit unusual. So, but I've been very fortunate to work with, an astounding number of really, really talented students. And kind of like Melissa, they're all so much better than I am. And I like to say it's only because I've stayed here for 30 years and I've picked up stuff from the people who have passed through in the last 30 years that I can look good. It's because I've saved up everything that everyone else has brought to the table.
Amazing. I'm just reflecting on this and thinking, I wonder if your male counterparts would ever say the same thing. And I don't know, I think I'm surrounded by amazing students too. And I always think, whoa, they're so incredible. But I wonder if the men in my lab or the men who are doing lecturing would also say it. And maybe that's something that we need to rectify. I'm going to come next to Professor Laura Green. She's speaking tomorrow. You probably all know Professor Green because she was president of APS, which must have been absolutely massive, focusing on science diplomacy and human rights, but is also chief scientist at the MAG Lab. So if you've ever wanted to do really high magnetic field measurements, you probably also know of her and holds incredible leadership positions in science and physics. So I wondered, Laura, if you could talk briefly about your career in physics and your kind of ideas about this amazing collective and this conference.
Thanks, Jess. That's very nice of you. And I'm really delighted to be here. Melissa, thank you for your talk and for all the comments and the comment. Let me just say that I do agree things are very different. I'm sure I'm much older than anybody on this panel here. And people I just turned 70 in June, and people of my age, all my girlfriends, none of us had any encouragement in physics. None. We only had berries. I can't say that there was a mentor. Later on, I found people that I'm still friends with now that mentored me. But the women, when I started graduate school, there were somewhere like 270 graduate students at Cornell and 4 women. And we are all best friends still. And we just learned how to get through it all. I'm really delighted that people can be convinced to go into physics in middle school, high school, college, and even graduate school. But like I've always felt, I always said that physics isn't my job or my career, but just who I am. And it was almost like being called to the cloth. And I think one of the reasons why I'm successful is because I knew I'd never get a job in physics. Right? I couldn't lose, right? So I was going to go sell shoes if I couldn't get a job, or after undergraduate, because I didn't know what kind of physics I wanted to do, but then I loved machining and building things. So I went into condensed matter, so I could have been a machinist. But I've had a lot of really lucky things. Like I just spent the last 2 days with PCAST, with the president's Council of Advisors for Science and Technology. And I was going to take this meeting in a different room. But then, of course, that was the science advisor to the president needed the room, so I was kicked out. So yeah, I'm talking with these people and it's fantastic. But I have gone through a lot, and that's something I want to stress. It wasn't all lucky and easy. And I think you do gain from they always say what doesn't kill you makes you stronger. That's not completely false, but you also want to remember the good things and build up your what they call resilience dividend. But I have all these great stories, like my PhD advisor sat me down and said, I'll make sure you don't get a job in physics. And I won that one. And how I managed to do that was sort of interesting. And we get along just fine now. But the other thing that I found was that I really did have a passion for physics, and I just couldn't get enough of it. I really learned my field really well. I knew everything about the materials, everything about how they're made, all the literature. But then also in graduate school, Kurt Gottfried, who many of you have heard of, probably many of you knew, got me to do some work on human rights. And he said, would you like to come with me and go pick up Elena Savine in the airport. She's been in jail in Argentina for 2 years. And I said, hell yes. And that started, and Elena and I are still friends. We met her at the airplane. She didn't speak English. She was quite terrorized, and she had a 2-year-old son. And part of that, I mean, I still focused on my work, but I started to learn how if you get a real foot in science, so I was on the AAAS board for a long time. I work with the Committee on Human Rights of the Academy. I'm moderating a panel next Wednesday, I think, on human rights. But once you have if there's other things you want to do with these societies behind you, you have a little more oomph. And so what I'm doing more than physics, oh, by the way, my physics is looking at novel materials, particularly novel superconductors, high temperature superconductors, what the Cooper pairing mechanism might be. Also tomorrow, I'll give you an overview of the magnet lab. So it'll be a fun talk. It won't be technical at all. It'll just be fun. But so then I found that I really also, besides continuing in my physics, I could also have an influence on science advising, science diplomacy on a worldwide scale. See, we've got Ukrainian fingernails on a worldwide scale. And it's just very exciting. And I think in the United States, it's harder and harder to get sustained funding. And so, my lab is still active, but I think it's harder and harder to do that. And so I'm really happy I can make a difference in these other areas. I get a lot of people ask me a lot, how do I go into these areas? And I'm happy to discuss it. But what I tell young people, make sure you get your career strong in the field that you love. And then what happens is you get more and more responsibilities. I don't know if it's administration or committee work or whatever. If you maintain that you still have a little bit of time to think about creative physics, this is the icing on the cake. And so just don't ever forget that. And I guess the other thing is I'm a strong believer in rites of passage. So when you feel like, first of all, you need your girlfriend, share emails, whatever you use to talk to each other. Because when you think you're going crazy and you're a minority, just talk to your friends. And I've got several friends I talk to. But you also try to remember of what got, when you feel like you can't dig out anymore and you know how it feels. Even the simple things like you're giving a lecture and you can't do the derivation right. Just try to remember some of the things that made you excited about physics. And the other thing I learned recently is get a physical box. And when something really good happens to you, somebody compliments you, a student says that was good, okay? Or you get an award, or you get invited to wow. Make a copy of it, put it in a box. It does great to overcome imposter syndrome. You have something physical there you can touch. So I'm happy to answer questions, but my journey is going to be a little different because I'm a lot older than you, but it's still fun to share. And I think I've seen just about all of it. So
it's amazing and absolutely incredible advice. And I really love that protecting time that you can just think creatively about science. I think that probably, if everyone in this audience, no matter what career stage you're at, remember that thing that you absolutely love and find time that you can keep reading up and keep on top of it. That's kind of critical. I love it. And also it leads me really nicely to Professor Nissanke, mainly because alongside Professor Nissanke's incredible work in astrophysics that you heard about earlier, and chairing and being on all of these boards of incredibly important, big, very huge space missions and observatories and looking for, the biggest stuff in the universe. But she does a huge amount for the kind of Dutch, the Netherlands astrophysics community and really advocating for women scientists. And, for me, has been a really powerful leader in learning how to call people out for bad behavior. And as probably everyone in the audience knows, in astrophysics, there's quite a lot of that. So I think coming from the back of talking about human rights and science diplomacy and your potential as a leading women scientist, maybe it's right to bring you in now, Professor Nissanke, and ask for your perspective.
Thank you, Jess. Thank you. That was a really lovely introduction. So yes, just for those who maybe did not hear my talk earlier, I'm Samaya Nissanke. I'm an associate professor in gravitational wave and multi-messenger astrophysics at the University of Amsterdam. and also the spokesperson of GRAPPA, our Center of Gravitation and Astroparticle Physics there. Yes, so I can say, I'll say a few words, I guess, about myself, but essentially my research is using multi-messenger observations, in particular gravitational wave observations of compact object mergers, really as probes of cosmology, nuclear physics, fundamental physics, astrophysics, high energy astrophysics. So I think that's about a one-line sentence about my research, but I'm happy to answer any questions about myself. So I was born in London in the UK. My Sri Lankan dad and my Japanese mom actually moved to the UK because my mother at the time in the 1970s was unable to actually pursue a PhD in Japan as a Japanese woman. So that sort of instigated, and that's why they ended up in the UK and why I actually spent then the next 23 years of my life there. I did my undergraduate and master's and then moved to Paris to do my PhD, postdocs in Canada and the US, and then returned to Europe, back to the Netherlands. Over the last 7 years. Since I think I got tenure, one of the first things I decided to do several years ago was to found, and I'm now the chair of the National Equity and Inclusion Committee in Astrophysics, so representing about 700 astronomers, astrophysicists, engineers in the community. And I guess the reason I decided to really invest time there was not only because of my own personal experiences and my own privilege. I had a very privileged educational experience and family support, but I also believed, as we've heard, that change has happened irreversibly for the better in the last 20 odd years. But not fast enough, yes. And I think that really sort of was the impetus that now I had this opportunity that I could really try to support early career scientists, particularly also women in physics. I actually started working in gravitational waves as an undergrad, maybe 22 years ago, I think. And until 2016, gravitational waves was not a very popular field to work in until the actual discovery of gravitational waves. I would say my career was quite bendy and there were lots of challenges. And I really did, there were times, of course, when I was working much more on theory and also preparations for data analysis and multi-messenger astrophysics. Multi-messenger astrophysics maybe even 10 years ago, 12 years ago, when I was invited to give colloquia, I would have very nice audiences, but a lot of people would look at me as if I was talking about science fiction. Yes, it was still this very strange thing. Yes, why would we spend our massive telescopes and point up into like random regions of the sky to look for a gravitational wave event? Yes. And so I do remember those talks, and I sometimes now go back to the same place, and 12 years on, 15 years on, it's quite a different reception, but it is just fantastic. I think it's a sign of science that we are now in this observationally driven field. And that for me has been just such a privilege and honor to experience in my own career. I mean, I just did not expect 2017 and this neutron star merger to happen after spending 10 years every day thinking about these events. Yes. And so it was really just a beautiful moment. I think following there, I have a few strategies and things I have sort of thought about over the years, but I think following on from a lot of what the other panelists have just mentioned, I think perhaps the most important one I had to learn myself through my own career trajectory was really this point that's been made, was basically to embrace who you are and where you're from, and also your love of science. And that was really very, very, it took me some time to get there. I think really realized that sometimes I did feel maybe a bit, I don't know, I was a bit different from my physics cohorts in Cambridge, etc. But really that actually I could contribute, and that I loved physics, and that I am who I am, and not to be afraid, I think, of doing things your own way. Yes. And so I think that there, Jess, I will pass it back to you.
I think it also, it's interesting that the comment about gravitational waves, because I think when I've been thinking about equity and what we can do to make more inclusive scientific meetings and things like that for ages. And LIGO has always had quite a robust code of conduct. Am I right in that? It's an extraordinarily large international consortium. And as a result, you have to have rules and regulations, or, you know, an outline of how you expect people to treat each other.
I think it happened actually, that's really an interesting question. I think, with international collaborations and consortia, and I'm a member of many of them. I would say even in 2010, these did not exist. So like in LIGO, for instance, our code of conduct came in much later, a couple of years later, but it is true that it was very much instigated by a realization that these, we are working in international collaborations and people are coming from everywhere, yes, and just that realization that there's an incredible beauty, but also that we have a commitment to each other, to be respectful, to be understanding, and to kind of come together, I guess, because of our love of science, gravitational waves, etc. But I would say it's really in the last 10 years where there's been a lot of emphasis on diversity, equity, inclusion there, and it really, and you see it now, yes, because I think it's great that you sort of thought it's been around maybe for even longer, but it really is that I think the early career scientists are the ones who are really pushing it forward, and I really admire them and the time and effort that they spend.
I think it builds on what Professor Franklin was saying about her students, that they want this now as well. And I think it's quite fantastic. If I come back to Laura, I'm going to call everyone by their first names. It's too awkward saying the whole thing. So sorry for that. If I come back to Lauren, particularly building on what Laura was saying, what was kind of your spark that got you into physics? What keeps you asking questions about dusty plasmas?
Well, it's kind of a two-part thing. So what got me into physics is because I did not start out in physics. I was actually a chemistry major, and I took physics classes in the summer just so that I would be ready to take physical chemistry in the fall with the good professor. And my physics professors that I had that summer kept saying, "Oh, you're really good at this. You should be a physics major, not a chemistry major." And I was like, no. But they kept after me. And I eventually did change. When they would talk about, oh, you're going to learn about these things in your upper level physics classes. And I thought that sounded really interested. And I didn't really get that in my chemistry classes. So that's part of why I switched to physics. So what really energizes me and keeps me asking questions, of course, are collaborations and going to conferences and getting a chance to really talk to other people and hear kind of wild ideas. Doing things like this, where you're hearing things from other fields that you see how they can kind of link in with what you're doing, even though it's completely different. That always keeps me coming back. But I will say, periodically you just get tired of doing the same thing over and over. And so that's why I really love working at a university, because you're teaching a class. So when you're teaching your class, you get tired of it at the end of the semester, then you get to do research, and then you do that for a while and you're like, I'm stuck. Oh, it's time to teach class again. Hooray, something new. So being able to pursue something new and find something new all the time makes it fun.
That's, I think the collaboration part is something also you don't really appreciate when you're an undergrad. You don't know that exists, right? Unless you have a fantastic professor like everyone who's speaking students do. But I think really finding that out and finding out that discovery is a team effort, is something that's really exhilarating. I guess I wanted to come now to Melissa and say, and it kind of links to the question in the chat, but does it ever get kind of tiring always being the first? Has it been tiring? Was it difficult at the start of Harvard when you were the first woman to get tenure in physics?
I think I was kind of busy during that time and didn't really notice too much. The only thing I remember is that maybe I talked too much a little bit. I should have talked a little less at the beginning. Just to get people ease into it. But I don't feel like that. I don't feel like I don't feel like I'm the first. I feel like I'm the last. We have a lot of women professors now at Harvard, and I don't know, 11 or something. And so it doesn't even seem like a thing anymore. It seems kind of a little bit embarrassing to have been.
That it's all. Was it a thing to people around you? Was it like now?
I'll tell you, I got it's the first time I've ever thrown up from drinking.
I'm sensing a theme here.
I mean, I think that, maybe the thing is being the first is a little bit different than later because, I kept thinking when I was up for tenure, they'd be crazy to tenure me. Look at, there's this Nobel Prize winning guy who is on the faculty, and he's so smart, it's hard even to walk past him without like light coming out and just getting you. And then thinking, oh, they'd be crazy not to tenure me. So, this sort of yin yang thing, because, you look at most of your colleagues and they just seem normal. There's always some. So this yin yang thing of thinking they're lucky to have you and thinking they'd be crazy to take you follows you through life. I'm hoping that isn't something that it doesn't sound like younger people have that thing. But I decided if I just do Tai Chi, it's fine. I have the yin yang, and then I do the Tai Chi, and then everything, I become a Taoist and everything is fine. I'm being a little bit funny, but that's all I can really think about that has followed me through about being first.
Did you have?
Yeah.
Oh, wait.
No, go ahead. So
you discovered this great role model kind of relatively recently, but did you have a mentor early in your career? Did you have that kind of, now we speak a lot about mentorship and kind of guidance and that, and how critical that is for navigating early stages of your career. But did you have that?
I had an enormous number of people, for reasons I cannot express or understand, be incredibly nice to me. I'm not sure it was a mentors, but a lot of different people stopped what they were doing and helped me when I needed help. Just people at all levels, like really, really amazing. Everybody's from the first day I walked into university without a high school diploma. So I've been incredibly lucky, but this is something different, my new role model. This is someone, there's lots of people who help you, but who do you want to be like? If I ask my students, do you want to be like me? They go, no, not really. I mean, honestly, like finding someone that is sort of somehow like you, that shares some things with you, is not so easy. And it hasn't been so easy because there haven't been very many women. I've had wonderful women all the way through who were, there were one or two older than me. I guess Laura's older than me, but she wasn't in my field. And she's actually not much older than me. So yes, I'm thinking a different way now. Can I just say one thing? I've decided that every student who's taken just a few physics courses has developed a little physics brain, sort of like a monkey brain or a lizard brain, So once you've taken a few courses and you had to do some problem sets, you develop a little physics brain. So now I feel like I have an enormous number of possible people I can relate to with our physics brains. My physics brain might be a little bit more larger part of my brain, but I feel like there's a lot of people now to be together with. And I think more about that than thinking about first or second or third. I think about this whole swath of people all over the world who have whenever they see something, they go, oh, I wonder how long it would take it to fall. Like they see something on a bridge. I mean, so I'm sorry not to answer your question about the first thing, but It doesn't seem relevant anymore.
I think it's kind of the perfect answer, because that's what you want, right? You don't want it to be relevant anymore. And you also,
right.
I hope everyone in the audience and whoever watches it later has those networks of support around them, like has that support within a department, because it's so critical for deciding what you do next. I wonder, and if you haven't read it, I'll send it to you, but have you read Carbon Queen, the biography of Millie Dresselhaus?
Oh, no, but I knew her.
So I thought you might know her.
Yeah.
But her story, it's a book by Maya Weinstock, who's the science librarian at MIT. She's also the person, I'm assuming everyone in the audience will know her, but she was who pitched to Lego the idea of the Lego Women in NASA set. So that set of women at NASA that Lego made, it was Maya who pitched that. But she actually, kind of coming back to your kind of story about Mary Gopok Maya had all of these extraordinary oral histories and interviews and things to build from, to get kind of Millie's biography, because people did that at that time. And, you know, I think we really do need to keep that storytelling and that writing and that oral transcription of people's experiences alive. Kindly in the introduction, Laura mentioned that I have this project where I write Wikipedia biographies of scientists who've been historically overlooked. And I've been doing it every night for 4 years. And I'm at like nearly 1,800. It's amazing. But
so can you just say that again? Wikipedia biographies of who?
Scientists who haven't had the recognition and the celebration they deserve. So scientists
So dead or alive?
Dead and alive.
Dead and
This
alive.
did actually mine, I have to say.
But
I suddenly had a Wikipedia page one day and I was like, who created this? And it was Dr. Jess Wade. So thank you, Jess.
But also for that process, for that and for writing books, whatever it is, you have to have some material to build on, right? And there's been a little bit documenting African-American pioneers. There's a project which is kind of the history makers, and it's done all these oral histories. But I really do hope there are people at Harvard, at MagLab, at all of these extraordinary places documenting everyone's story, because it's so much bigger than just your Google Scholar profile, right? It's so much bigger than that, and I think we're losing that a little bit. But that's probably a conversation for another place. I really want it to happen more. Maria, I wanted to come to you now and talk really, like, what gave you the passion to do this work fighting for mothers in astronomy? Did something inspire you to keep doing that? And has anyone helped along the way of doing it?
Well, my husband helped. I think I was very lucky because when I was pregnant with my first child, we look at our salaries and they were the same. And then we look at the passion we had for our job, and my passion was big. And he said, well, I don't mind to quit my job and spend time at the playground instead. I like to be outdoors. So that was the big step. So, but thinking backwards, I mean, then of course you are a mother, so it's not that I am in the office 12 hours a day or anything like that. I don't work weekends or evenings or anything like that because it's just too hard with children. But I think that when I look back, I was lucky, but like my advice when people ask me, okay, how do you think one can have a family and be a woman scientist? And I think that teamwork is really, really important. So I have to thank my husband because we set everything very clearly, who is doing what, and we try to do it in a fair way. Now he has a job for many years. He went back to work when the smaller children started school. But so the job didn't finish there with the family. But then we have a very structured who is doing what and when. And so my advice is that, you know, you fall in love with someone and everything looks wonderful and very romantic. And you think, oh, of course, everything's going to go perfectly. But my advice is, well, maybe you can also over a romantic dinner also discuss, well, how do you think you want to organize and manage a family so that there's no someone who has to lose their career and someone who can pursue it, but both people can kind of do both things together. This is what I hope that the direction will be in gender equality within the family in general, in society, not just for scientists.
Yeah, we have kind of quite progressive movements and calls for shared parental leave across Europe, I suppose, certainly in the UK. But the huge challenge to overcome is the gender pay gap, and that it's often kind of prohibitively expensive for you to not have the man working. So I think it's kind of it's multifaceted, but I am so impressed, and I think probably young women ever are very grateful for everything that you're doing. I think probably you know, if people in the audience have questions, please do put them in the chat. We probably have about 10 more minutes of everyone's time. I know for Adele, it's 2 a.m. in the Philippines. So I really am and absolutely so grateful to everyone for sticking around and to everyone who's speaking on this panel. I wondered, Laura, you kind of touched on it a little bit when you said everything's changed so much since you started. But what do you think kind of the biggest changes you've seen for young women or people from other historically excluded groups have been in physics, and what could we do more as a community to keep pushing for those changes?
Oh, that's a loaded question. I mean, I think we still need to make more changes, and I think there's still real barriers for underrepresented minorities in physics, a lot of them. But it's very different than it was because there were no rules about any kind of harassment. And it just didn't matter, you know, the kind, you know, I don't know if it was like that in high energy or not, but certainly in condensed matter, which is very macho about, you know, building equipment and stuff like that. I don't really know, but there was just nothing there. I mean, when I started college, abortion wasn't legal, for instance, so there was no women's rights. And then there was nothing that had to do, I mean, when I had my first kid, I was saving up sick days, right? You know, the United States had nothing. I was always surprised at how far ahead so many other countries were than the United States. And there was no leeway. So with my husband, childcare was so expensive. If one of us would have stayed home, we would have had a lot more money. But of course, that wasn't an option. And also in my age group, the idea of it was pretty rare to have a partner who was going to pull half the weight of the home. It wasn't even thought of. I mean, that would not cross my mind. You know, I would worry about, man, I wouldn't think about not having evening or weekend meetings, even though I was stuck there and having, you know, to worry about the childcare when I got home late at night. We just didn't think about it. And I think one of the things that have changed, even women that are 5 years younger than me and 10 years younger than me, just became more aware. And I often look to my younger colleagues a lot because my first reaction is to just take it, never #MeToo. I still could never do that. We just did that. And I'm so proud of my younger colleagues, even ones that are just a few years younger than me, that had the courage to stand up and say, you know, and I would ask them to do this and they would have the courage, which I didn't have, and say, I can't do a 5 o'clock group meeting because I have to pick the kids up. I can't do a 5 o'clock group meeting because I have another job. And just stand up for yourself and your family. And if you feel unsafe, say something about it. And I just, all the time, I look to so many of my younger colleagues when my first reaction is, you know, just deal with it. And when I think that something doesn't look fair, I ask my younger colleagues, men and women now, you know, how would you deal with this? I need help here. I really do, because I'm really old school, but I've learned a lot. Another thing that I want to say is that when I'm asked to do, you know, how to life career balance, I used to say that my life was a controlled crash, but I've hence taken out the adjective controlled. And so we just sort of dealt with it, and my kids did fine, and they're great. And there's ups and downs, and you know, you don't have, you can figure it out. Even if you don't have a good teamwork with your partner, with other people, you can figure it out. And then that's what we have each other for. You know, you say, my department chair won't let me, yada, yada, yada. You say, come to me, I'll talk to your department chair or your dean. So we also have to stand up for each other. I've noticed that if I'm visiting another university, it sometimes is more effective if we stand up for another woman or underrepresented minority from being outside that institution. And the other thing is that I just love these things because I learned so much from all of you. Thank you.
No, I love everything you just said. Who was that? Sorry.
Yeah,
Laura.
I was going to say, you know, Laura, you mentioned that women are now saying, oh, I have to go pick up my kids at 5, but it's also the men now who say, I can't do the 5 o'clock meeting. I have to go pick up the kids. So it's just getting spread out a lot more. Which,
yeah, it's wonderful.
And you're incredibly lucky if you have a husband like Maria does. And my husband who said, you know, we're going to take this on. We're going to stay home with the children. That was incredibly lucky on my part, and it sounds like Maria as well. But I think that is finally kind of spreading and becoming a bit more normal. They're not so strange to be the dad on the playground, even though often they are the only dad on the playground.
But I think it's quite important, isn't it, that this like it does just become normal, and everyone recognizes not only is it normal for men to take on some responsibility of looking after kids, but also that actually progressive movements to make science more inclusive and equitable benefit everyone. You know, it's great for everyone if you stop working at 5. It's fantastic if a conference has nurseries. It's amazing if places give you caring grants, whether that's to look after elderly parents or look after children. I think, you know, often people are criticized for doing this work, but actually the outcomes of it are good for the whole of science. And that's what we have to keep kind of focusing on. Samaya, I thought maybe you could comment briefly on kind of movements within the Astro community and kind of how people's voices have come together there, maybe, if you feel comfortable doing it.
Yeah, I think so. It's been an interesting time, I think, for astronomy in the last 7 years, I guess, because there have been quite a few high-profile cases and harassment that have obviously come out very publicly. And one question that often comes up is it something specific to astronomy? You know, we don't hear this maybe in all other disciplines, etc. And so it's something I don't necessarily have an immediate answer for, but I do think that astronomy, yeah, there are some, I think the gender balance in astronomy is quite, so I work in both astronomy departments and physics departments. So I have joint appointments in both. So I do get insight into, I guess, the different efforts that are going in terms of equity and inclusion in both communities. And one thing that I do see in astronomy is that, and this is a huge generalization, so I do preface it with this, but you know, there tends to be, especially in newer fields, for instance, like exoplanets, etc., there do tend to be a much more higher kind of gender ratio in terms of equity. So many more, I would say, women and other underrepresented minorities. And I think that has been a conscious effort in the community and in these sub-communities, really from the then relatively young leaders of the field who had made all these very big discoveries, actually prioritizing that, yes, so really prioritizing hiring women students, then in short, mentoring, retaining them, and making sure that they all go into faculty positions. I mean, there has been a big support system, and you see that, for instance, if you go to these conferences, etc. And I think that has very much to what was discussed, that has empowered people's voices. Yes, I think there was very much this feeling that actually, because I also was of the generation where I just kind of was like, oh, that crazy thing just happened to me, but that was normal, yes, and just sort of normalized a lot of unacceptable stuff that happened to me when I was in my 20s. It was like, okay, yeah, that's just being a woman in physics. And then I realized, you know, in the last decade, actually, the students I was talking to and the early career, they were like, no, like, this is not normal, what's just happened to me, etc. And it was that kind of empowerment, and you feel it, yes, that they are the ones saying, this is, yeah, this doesn't happen in many other professions. And I think that we do have to kind of address these issues. So I think that has been quite key, is that, and it is unpleasant for the community, but I think having these discussions and having this desire to move forward has been really important. And now my generation, or the generation just below, they all do speak up. Yes, they went, just when you said I speak up, I was quite surprised, because I still feel very I guess timid. Did not grow up, yes, kind of on, tweeting and saying this and calling people out. I see myself very much as not doing that. So I was very I do, but I do really admire my colleagues who can do that, yes, and who are able to do that, because they're doing it for awareness and for change, and it is happening. You see it.
Yeah,
Sorry, that was a very long answer.
No, it was a perfect answer, but it's basically taken us to time. I think the nice thing that I did was really perfectly answer. There was a comment from Yasmin that came in the chat about making your voice heard in theoretical physics, which has a huge underrepresentation of women and other historically excluded groups. But I think you kind of answered it, that you have to find your people. You have to find that network. And I think historically, you had to find that network physically, but actually now you have all of these opportunities, probably not on Twitter after Melissa's great comment that we've all got to get off Twitter. It may be on Mastodon, it may be on Instagram, it may be in TikTok, but finding that there's a international network called 500 Women Scientists. They even have a fellowship for women scientists from historically excluded groups. There's 500 queer scientists, there's Pride in STEM, all of these networks. I would engage with them. It's been fantastic for me to have those communities, when you're doing a really long experiment, or when you're at a synchrotron or something like MagLab, and you have, 24 hours a day that you have to stay up. It's great to connect to like-minded women scientists all over the world. And I think social media gives us that opportunity to do that. So Yasmin, wherever you are in the world, I hope that you can connect and find those communities. I want to give everyone on the panel a chance to say some parting wisdom, but also just to comment myself and to kind of reflect. I think the key thing that I'm taking away from this is you've got a group here of incredibly passionate and inspired physicists, and the way they keep passionate and inspired is by surrounding themselves with fantastic people and teaching and being around students and being engaged with things that they love alongside their physics, like science diplomacy, like advocating for families. And I think keep that passion alive, have your science passion and have whatever else keeps you going, and make time in your schedule. Don't become overburdened by commitments that take you out of the science you love. And when it all gets a little bit too much, just keep remembering that thing that gave you that first buzz, that thing that gave you that first rush about wanting to become a physicist. Probably also we could take away a key point that you don't have to have it all planned out. Exactly. When I've watched the talks this morning, everyone's scientific expertise is so incredible. And you often feel like, oh, they must have known they wanted to do that from the beginning, or they must have known that this was this area they were going to go into, and they must have been reading up on it for ages. But whilst it's incredibly important to keep on top of the field, as Laura said, you've got to know your stuff. You can work that out as you go along, like find the thing you're passionate about, and it might take you to another room and it might let you have another conversation, and to just keep fighting. I truly think this is an incredible group of women, and I really hope that you have learnt a lot from them. And I might come around one by one to give everyone a chance for a parting thought, but I want to say, if you need to save the chat, because the comments in the chat are amazing. So hopefully Laura's on that. I assume Laura's on that. I might come to Maria first for her closing remarks on this incredible group and this great hour we've had.
So yeah, thanks everyone. It's very interesting. There's so much more to say. We could stay another hour, but I know it's late for me too. But I want to say two things. One that is connected to what you just said, Jess. And this is, to learn to say no. Somehow, if you're a woman, you feel a bit like you have to be nice and you have to say yes to everything. And I'm learning, even I'm already 52 years old, and only now I'm starting to have more and more courage to say no and no and no and no, because I want to do my research. I don't want to give my time for free to anyone who asks for it. So that's important. And I would say that to me, it helped me not to take myself seriously. This is the quote that I mentioned at the beginning, that I take my work very seriously, but I don't take myself very seriously. And I think this helped me because it makes everything a bit less scary, in the sense that I'm not up there and I'm gonna fall from some like pedestal. I don't know in English the word, like I'm not gonna fall down because I'm already down there, and so it's a bit less scary. I can make mistakes, I can say silly things, it doesn't really matter. So that helped me, I think. So thank you, everyone.
Okay, perfect advice. I think say no and don't take yourself too seriously. And actually the people I admire most in life do not take themselves seriously at all. If I come over to Melissa, I'm assuming it's going to be don't smoke, but something else as well.
Can you hear me? Yeah.
Perfectly.
No, I'm actually thinking that take yourself seriously enough that I'm interested in what you're thinking about, and write it down, and take yourself seriously enough that someone's going to want to know what you were thinking. So I understand what you're saying. Like, I get that. I'm a goofball, but maybe taking ourselves more seriously is a good idea.
I think that's also critical. Certainly you have to be passionate enough about what you're talking about. You know, that awful business thing that you have to have your elevator pitch. You have to have your thing that is the buzzy thing that you can say to anyone in any scenario, and take yourself and take that seriously enough, or else you're never going to convince anyone. Maybe on my screen, I'm going to come to Lauren now.
Sure.
Closing thoughts.
My last bit of advice would be, you find what you're looking for. So if you're looking for people to be mean to you and pick on you, that's what you're going to find. But if you have the outlook that actually you're a good person, good things are coming to you, there are good people in the world that want to help you, you're going to find that as well. So just changing your mindset can help a lot in getting where you want to be. I always, somebody said, keep the panel positive. I know that's hard to do in physics. I was like, you can be positive, you bring the positivity, and then you can share it with everybody else. And I've been fortunate. I know that bad things have happened to me, but those were weird people. That wasn't because of me, it was because they had a problem. So I just kind of let it roll off and say, it's not my problem, go on.
I love that. I've actually never heard that thought before, that you find what you're looking for, but it's completely true. And in all of our interactions, whether that's in the lab, in the lecture theatre, on social media, if you surround yourself by people who you want to be a bit like, you become a little bit like them as well. So thank you. I think that was so critical. Samaya.
Sorry. I thought that was really good too. I just want to say that if you don't tell people what you want, you probably aren't going to get it. If you want to be on a committee, you should tell people. This is something I learned when I was 58. Sorry.
And they will jump at the chance to put you on that committee.
I've written all of these down. I really like it. So you've kind of got to find what you're looking for, surround yourself with great people, but also you've got to make it known what you're looking for, or else it's people aren't just going to give you a massive magnet or a great spectrometer unless you tell them that that's what you need. Samaya, if I come to you now just for a closing reflection.
Yeah, I think reiterating some of what was just said, I mean, search for your networks also outside your own particular field. Yes, so be active. If you want to ask someone for mentorship, go up and do that. Yes, this was something that I realized relatively late on in my career. Yes, with people I really admired or aspired to in some sense. And so I would recommend that. Also, I think choose your battles wisely. This is particularly in the case of like equity and inclusion, or in your faculty, yes, do conserve your energy and protect your physics as well as your non-work time. I think especially what Maria said, and as a mother of a young kid, definitely that non-work time is essential, yes, and I'm glad, because it keeps me also sane, I think, in some sense, amidst the chaos. And then I think also choose your collaborators wisely. I've had such I'm so lucky, because there have been such wonderful friendships that have developed, and just having fun doing physics. And so finally, just keep your eye on the ball. Yeah. And just, if it's what you want to do, just go for it. Yes. And not to say it won't be easy, and the challenges will evolve, and they do evolve as your career changes, but, keep that special.
Thank you so much. Yeah, thank you. No, thank you. That was perfect. And I'm incredibly aware of how much time we're taking from everyone. So thank you so much for staying around. And just Laura, coming to you now. I mean, you've contributed so much for physics, and I hope people are recognizing and celebrating that, both in societies, diplomacy internationally, but also just physics itself. So maybe a closing remark. No pressure. But the women of the world in physics are watching.
So first, I want to say, Jess, you are an amazing moderator. I'm very impressed with you. And if I need to ever moderate anything again, I'm going to ask you for advice. And speaking of advice, we've had a lot of wonderful comments. We've had a lot of diversity in opinion here. And I'd like to see diversity among this diverse group. And I think my one piece of advice will always be, we need to stay in touch with each other. And this conference, wow, has played a significant role. I didn't know a lot of you, right? I knew some of you. And let's just not worry about, we're all very busy people, but if someone wants to ask me for advice or tell me I screwed up or congratulate me, I want to hear from you. And if I don't answer, send another email, okay? And I would just like to see this diverse group of very interesting women, men are invited to stay in contact and share experiences, because we've had all of them, and it's great to know you guys. Thank you.
Thank you so much. I'm about to send you about 50 emails, I think. I've been waiting for the invitation, and now they're going to come. Thank you to everyone for watching. Thank you so much to everyone who stayed up in really late nights, and everyone who's connecting very early in the morning. I'm going to hand back to Laura to say amazing work, but not just Laura, everyone who's been working with Laura for this whole incredible conference and for making this happen. Thank you.
Yeah, thank you so much, Jess. I want to close not with my own words, but with a person who wrote something in the chat. So this person said, thank you all for sharing about yourself and your experience, and for the encouragement. It's an honor to know that we have women scientists we can draw inspiration from. Thank you to all of you staying up late. It's past 3 a.m. now in the Philippines, and it's all worth it. So thank you. And I can only give this back to you. So thank you so much for joining this roundtable discussion. It was really an inspiration for me as well on a personal level. And thank you again, Jess, for being the moderator of this discussion. It was really wonderful. So thanks a lot. And we'll close for today. Bye.
Good night. Bye.
Bye, you guys.
Bye bye. Thank you.
Bye bye.
Thank you.
Yeah.
Bye.
Laura.